Hi everyone, welcome to my tutorial series again on the some advanced topics in with Sumo simulations. So far we've looked at how we can create or rather generate a vehicle output from the simulation. Um, so so we have generated only a single simulation output, that is an emission output. So in this video, we are going to look at how we can generate or rather consider the stochastic aspects of simulations. So in order to doing so, so you don't ideally rely on one simulation output. Rather, you try to work with uh, you know you run the simulation repeatedly multiple times by changing the random seed, and based on that you generate results. Now it can be automated using what you call this runSeeds.py Python script. What you have to do is you have to provide a set of or rather the configuration file, and then you need to provide a set of random seeds to this to run on, right? So therefore, yeah, what we are going to do in this particular uh, video is that we are going to try this, and we are going to run. We have all whatever the configuration file that we have. We try to run it multiple times and generate outputs. Right. So before moving to the video, if you have followed this content so far, and if you think it's useful, please consider subscribing to my channel. Right. So we'll dive straight into the video. So let me close these things. Right. So this is where we stopped. So I mean, now with this command, we ran the simulation only a single time or just one time. So therefore, I'm not going to use this anymore. So probably, therefore, I will delete this result that was generated as well. So now I have a fresh kind of rather empty directory. So let me call this, and uh, rather we'll try to run the simulation with multiple random seeds. Now, for this, the way that I look at it is I first create a set of random numbers, or rather set of random seeds. Rather than me generating them manually, I'll take the support of the random uh, package in Python and use that to generate multiple random seeds. And after that, we can use those random numbers as an input, and so that on those random numbers, the simulation will be run and generate the outputs, right? So for that, I will import random, and then we can so we'll change the random seed. Now the random numbers that are generated, I want it to be a fixed set of random numbers to be generated. So therefore, I can set the seed. Let's say that we take some seed value, and then from random dot seed, I can set the seed, and then I can generate set of random numbers. So random dot find int, so integers. So I can rather I can generate a set of numbers as a list, right? And here the random integers that will be generated between, let's say, within this range, and I will generate, let's say, 10 random numbers. Now, these generated random numbers is a list of integers that will the resulting variable will be a list of integers. So therefore, I want it as let's say something like this, or rather, let's keep it simple. Something like this, right? So what I'll do is I'll join it with a or rather convert those integers to string and separate it by a um, by a by a convert, right? So random numbers, right? So this will give me a string of those random integers that were generated as a string. So now I'll let's say multiple runs. Let's say this. Now in this variable, I'm going to kind of use the runSeeds Python script. So run seeds.py, and then you need to pass the configuration file. Configuration is run simulation.sumo cfg, and then I can get the repos, or rather it will print what it does. And then obviously what most important is to pass the set of seeds that have been created here. So the variable will be like input argument will be seeds. And then since I want to pass that variable, I will convert this part to an F string and then pass the variable. And right. So then I can use the and let's say this is my step 4 now. Let's say something like this. Let's try to make it big fancy. Use this. Right, something like this, right? Let's see. This should right. So we'll let it run. So let's see how it goes. If successful, this uh, result subdirectory should have multiple files generated. Rather, 10 files should be generated. Right, you see now the emission output is generated for 64607 random seed. So that's a random number generated through this process. Right, so this will take some time. We'll wait till the process ends. I'm not going to edit this video, right? So you have to bear with me on this, or else you can use 2x, or rather skip this part if it takes too much time. But I think it will be, the results will be available soon. As we see now, it's for 11332 random seed. This was generated. So likewise, yeah. So yeah, so I think this will take its time to run. But the key idea here is that now different emissions are being, or rather, the emission outputs are created for the same, same inputs that we have provided. But the only change it does is it change the random seed under the hood, and so that each run is slightly different, and thereby the produced outputs will be different. So if you look at it, for example, here, if you look at carbon dioxide absolute or total emissions of carbon dioxide within this first 5 minutes is closer to 76 kilograms. That is the total amount of emissions made by all the vehicles. Now, in the next run, it's earlier it was like 76.96 kilograms. In the next run, it's 76.77 kilograms. In the next run, it's 73.89. So slight differences, right? Because that's what it actually does. So the each time when the simulation is run, the slightly at slightly different settings it will be run. So thereby the outputs generated will be slightly different. So now if you have all these, let's say 10, or if you can run further runs, let's say 30, 40 runs also, it's possible to run depending on the computational time it requires. And based on that, we can calculate the average, or rather we can calculate some average and standard deviations of these outputs, so that you can present your results with some sort of confidence range, or like confidence values, or rather with the uncertainty also included, rather than saying a single value which is anyways going to be a wrong value. So that's what I wanted to show in this video. So this will I think it will take much time, but 1, 2, 3, 4, 5, 6, so 4 more runs to go. But it will take a couple of minutes to complete. But the key point here is that you have multiple simulation outputs which you can later use for analysis. So I'll end this video here, and once this is run, once the runs are completed, we'll see on a next video as to how we can take these outputs and convert them in a meaningful manner, so that we can present it. Right. So thank you for staying with this video, and I will see you soon with another video and complete the rest of the tutorial. Thank you.